Hi everyone, thank you for joining this session to listen to my talk. I am Shubhi Asthana from IBM Research Almaden, and today I will be presenting multi-cloud solution design for migrating a portfolio of applications to the cloud. This work I have done with my colleagues Ali Megahead from IBM Research and Elias Ayub from IBM Services. A short bio of myself. I have been doing research and development for the past 5 to 6 years in the area of cloud services, IoT, and predictive analytics. In my free time, I like to blog on Medium as well as take part in hackathons. So let's get started. We know that the use of cloud computing is increasing rapidly in many organizations, and they want to move their applications to the cloud so that they can make use of advantages like low cost, accessibility of data, and elasticity. Also, to further utilize these advantages, achieve maximum flexibility, and avoid concentration risk, the organizations want to spread their applications across different cloud providers. So, they want to have basically a mix and match of cloud services. And hence, this comes to up that they would like to have something like a multi cloud solution. But there are many challenges that come when you want to migrate a set of applications to the cloud and have a optimal multi-cloud solution. One is that the client typically has many applications that they want to migrate, and not all the applications are documented well by the client. Hence, one has to go back and forth with client to get all the information and understand whether they're cloud feasible or not. Secondly, client typically has their own set of features that they want in the cloud provider, like the database, the security level, encryption level of data, etc., which has to be factored in while recommending cloud providers. Thirdly, some applications are built with legacy software and they need an architect overhaul for cloud. And hence, the clients have to evaluate what is the effort required to re-architect an application and whether they want to move it to the application to cloud or not. So, in our prior art, to the best of our knowledge, we have seen that there has been some work done in cloud computing optimization and analytics rather than multi cloud solutions, but not a lot has been done in that area. And also, there's no analytical automated way of efficiently recommending a multi cloud solution. So, our proposal here is how can we recommend the optimal set of cloud providers and create a multi cloud solution for the client. Here, we take in all the features of the data which is collected from the client, and we provide recommendations for a bunch of applications instead of one application. We evaluate what are the cloud providers available and give the best fit of optimal set of cloud providers that would fit these applications. So, our proposed solution is a four-step methodology. Firstly, we perform text mining of the data. The data is the cloud features data that we have, and as well as the application features that we have. And once we have all the data, we evaluate whether it's cloud feasible or not using a dependency graph approach. Next, we build an AM matrix of all the applications and the features that we want to evaluate on, like cost, security features, secure service level requirements, etc. And lastly, we build using an optimization model. We build and find the optimal set of cloud providers that would fit for these applications. So here is an overall methodology, a flowchart of a methodology where we are taking as an input the metadata of the applications that we want to migrate to cloud. These are taken in as inputs to our model where we perform text mining on the semi-structured data for each application. We evaluate whether it's feasible or not using a dependency graph, And then we build evaluate the features of the applications and build a matrix of applications versus the service cloud providers that are available. And lastly, we build an optimization model, so that as an output we have a competitive solution comprising of different applications and the corresponding services based on requirements of the client. We also factor in what have been the historical recommendations for similar applications of cloud providers, and what are the client requests for the cloud features. So let's go ahead and take a look at the stepwise process. So first we are taking the metadata of the application, like the number of users, the geography of users, investment on application, security and compliance agreement, the geography of database where data is collected, software platform, authentication server, etc. So we have this in a semi-structured document, and we use text mining to extract these tags, the data from the tags, and map them to relevant tags or keywords. So by identifying the keywords here for each feature, we can take those corresponding information and label them. So for example, we have number of users for the app is 455 in Europe. So our tag over here is users, and we extract the value 455. This way we have a set of tags that are required to ensure completeness of application of information. So if suppose we do not have a tag for investment on application, we go back to the client and request for that data so that we can process, go to the next step. Next, we evaluate whether it's cloud feasible or not, the application, and we use the GraphML model to build this dependency graph. I would show you in the later slides how this dependency graph has been built using an example. But essentially, w- after we build a dependency graph, we can identify what are the dependencies within the application, and then using that, we can rank whether the application is cloud feasible or not by evaluating based on few features, like what is the business need to scale, whether they are running out of capacity or not, whether they have architectural flexibility or global scale. So as you can see here, this is the old version of the application before movement to cloud, and this is projected version of application. So using this and the feasibility graph, we can understand whether we want to move this application to cloud or not. Next, we build a matrix of applications versus service cloud providers. So here we are using a weighting function on the different characteristics, like cost, the quality of service which is provided, the coverage, and the security. So these are some of the parameters that we use to evaluate which is the cloud service provider that would best suit the needs of the application. So we want to have like minimum cost and maximum coverage of the services. And using that, we come up with some service providers which would fit for the application. And lastly, we build an optimization model for the current set of applications. Here we are trying to optimize the cloud service providers based on constraints, like we want to ensure maximum set of coverage. We want to ensure that all the app cloud providers do fulfill the security requirements of the data. And we also factor in constraints, like suppose two applications cannot be in the same cloud provider or same geography, then we factor in that too. So an example use case, we took an application of from a global IT company which had to be moved to migrated to cloud. They had more than 100 applications that they wanted to migrate, and this is an example of how we build a dependency graph based on values like web, authentication, platforms, and data storage. We took the data that we had from the text mining and we mapped it across these four categories. And you can see that there is like some dependencies here shown in the dotted line. For example, there's a different this dependency between the number of instances and the software platform where it is hosted. So after we build a dependency graph, we evaluate it using questions like, does it have immediate business need to scale? So it didn't have scalable storage. It would require storage capacity to make it scalable, and that there were dependencies on it. Then we mapped it to what are the cloud providers that would suit based on the constraints like coverage, QoS, security, and cost, and we came up with a multi-cloud solution here. So we presented a method where we prepared a multi-cloud solution for a client portfolio of applications using methods like text mining, dependency graph, and optimization. And we evaluated our method using a real-world application. For future work, we want to enhance the text mining procedure and formulate the model properly using the optimization model formally. And we want to apply this to a more bigger real world data set to test its applicability. So I hope you found my talk insightful. Please let me know if you have any questions in the Q&A, and I would be happy to answer. Thank you.